Hey y'all, welcome to the channel. Today we are going to discuss about the one of the most famous and asked question, that is describe solid principles in the interview. So solid principles we will be discussing not in the first in the form of a technical terms. We will first go through the stories, like we can have some real world examples so that how exactly we are using these solid principles, because if we go with the real world examples, we would be able to understand and learn in a more better manner rather than we have to just mug them up. So I will be going first with the some of the real world examples in order so that you can correlate like how we are using the solid principles in real life, and then we will think like how we can implement in the code. So let's start. So as you know, this is a full form of solid principles. S stand for single responsibility, O stand for open closed, L stands for Lisk of substitution, I stand for interface segregation, and D depends density principle inversion. So let's start with the first and the foremost, that is known as the single responsibility principle. So as you can see in this, I have taken a small example. Like we have few of the footballs, like we can say different types of the balls that we usually we can play with them. So as you know, this is the volleyball, and this is basketball, this is rugby, and this is football. So the point is, like if you are willing, like hey, you are like come let's play. So you ask your friend like, hey Sam, can we play? So you are like, what game you want to play? So if you want to play basketball, so it's pretty obvious you need to play with basketball. So you cannot take like rugby or a football to play. So in this manner, it means like basketball is only used to play basketball. Like just understand, like we have this volleyball. This type of the ball is used to play for in the volleyball court. We cannot use it to dribble and use it this volleyball to play in basketball court and use it as a basketball. So it means like every ball has its own specific function, like its own specific use. You cannot go around and just mix them up. Like you can use this football to play cricket, no you cannot, or badminton. So every ball is used for a specific game. You cannot interrelate them, and if you try to interrelate them, they cannot be used. It won't be very fruitful, and you yourself would be confused. Hey, why this ball is not working in the basketball court? I'm trying to dribble it. You cannot dribble it. So things would be tough for you. You can dribble. You need a lot of energy. So this is single responsibility principle. This indicates like every ball is used in its own different game, and if you try to muggle them up, if you try to jumble them up, the point is you can play with them, but the things will come with more. You have to pay a price for it. You have to put your more energy, more efforts in order to play a smooth game. So in this similar fashion, we have the single responsibility principle in coding. So the code we will discuss once I finish all this real world examples, and then we will switch to the code. So here is the open close principle. Open close principle is basically like, let's say you have a house, you purchased a new house, and this is the foundation of your house. So it is like you have this foundation, and in this foundation you cannot like just like ignore this foundation, and you can ask your interior designer, here directly come and just design my house interior. You cannot do it, like it is not possible practically. You need to first have a proper foundation, and after the proper foundation you will be having, then your wooden work is done, then your other proper foundation building blocks are being made of your house, then only this part you can say now it is ready for the development end. Now you can decorate it. Okay, so you can have your house where you can put the interior as per your wish. So basically this was the basic foundation building block, and then you just decorated the existing one. You do not like, you cannot like go ahead and back and then say to the architect or the civil engineer, hey man, this wooden like lofts I do not like at the bottom of my window, just remove them. You cannot, like these are the things that are required. Like if you do not put the base foundation with the wooden floor, then your house might collapse. So in this same manner you cannot go back. It's not a good approach. Like if you try to just dig with this existing foundation that you have built off, so you might come up like you can collapse the things. Okay, the things might not work in your favor. In the same manner, we have an open close principle that basically deals like whatever things that are existing, do not touch them. Just you can decorate them or you can use them in a new way. Okay, but do not touch their basics or their original implementation. This is how I want to explain you open close principle. With the code wise, I will just take you in few minutes. Then we have Liskov substitution principle. Basically, Liskov substitution principle means like whatever, like this is, let's take this is basically, as we know from the picture, this is a tiger and this is a lion and this is an elephant. As you can see, basic emojis I have taken. So the point here what I want to explain you guys is like we have the tiger and lion from the cat family. As we all know, like this is basic, like we learned about the families, human species, and like here we have animal species. So this is from the cat family. So one day you cannot come and you can say, hey elephant, could you also come up in the, you and lion can tie up from the cat family and you can also come into our family and then we can take you in the cat family. No, you cannot. Like things that are been already there, you cannot touch their functionality, or you cannot touch the originality of that thing. Okay, so if tiger and lion are only from the cat family, you cannot bring it into the elephant and just change the entire order of the cat family. Okay, so elephant will be in its own different family. Okay, so this is what the risk of substitution principle means, like whatever the things that are coming from your previous hereditary, um, coming, let's say, from, in general words I'm saying, coming from a generational to generations, we should not touch them. We can just take them and add them or bring something to the table to the existing one. So similar way, elephant cannot be the part, but we can say like yes, these all are the part of the jungle and they are the, we can say they are from the animal kingdom. Yeah, this works for me, I'm fine, animal kingdom we can go ahead. But if you're saying elephant please come into the tiger in the cat family, no, that is not digestible. So in the same manner, inheritance, like let's say we are having a class and there is an inheritance. This is a parent class and this is a child class. So it should not change the functionality of the parent class. It can just take the functionalities and add few functionalities to itself that he or she wants, but should not change the existing ones. This is Liskov substitution principle. In few minutes we will be digging up the code. Now here comes interface segregation. This is quite important one and most of the people just mingle this. So this is, let's take a very serious, like simple example. So this, like we have a girl and this, we can say this is basically a shop and we have the shop which is having some grocery over here, and let's say Lily wants to go to the shop and she asks the shopkeeper, hey I want a candy, hey I want, like my mother asked me to bring like $10 of, like let's say any grocery, and I have only one, and she gives up, give the shopkeeper let's say $10, and then the total bill was around let's say $9. So what the shopkeeper asked, like hey can you please take a toffee or a candy for $1, I do not have the change. Okay, so Lily can take it, but the point is Lily is bit, like she is stubborn. She says like hey I do not want the trophy, I want my $1 back. So this is what exactly interface segregation means. Like you cannot, like Lily wants her $1 back, she do not wants, like she want to have a candy, we cannot force her. Okay, so we, the shopkeeper cannot force her, so anyhow she need to get that $1 and she need to give it to Lily. So in this manner Lily is being like stubborn and rigid enough, like she wants, like no I am not going to change myself. Okay, you have to give me the things, simple. Okay, so this is how interface segregation principle means. Like interface segregation is like we are having multiple things and we do not want the existing things to be changed. Okay, we are not allowing the like if you are a user and you want like you only want these couple of things, like let's say you only want $9 things. Okay, but what now, shopkeeper is forcing you to purchase extra $1 also. So this is not a good approach. You cannot force anyone to take this $1 also, like you have to return them what they want. Simply here also integrate segregation means like we have if many functions written and if I want to use only 2-3 functions out of it, so why this code is forcing me to take all the 10 methods or the functions? I, where whatever I want as the user, I want to use only those functions only. This is how interface segregation comes into picture. So as from the example we say, like Lily also been, she wanted an interface segregation, she also want like I only want $9 purchase and I want my $1 back, I do not want your forceful items. Okay, so let's see in the code in next few minutes. Now we have dependency inversion. This is also a very real world example I'm taking. Let's say here we are having like Adam. So what Adam is doing, basically Adam is into let's say he wants to code into C++. Okay, he is more into familiar with JS and or let's say C++ or C. So or Objective C we can say. So here he is been forced to write code in Java, and being forced to write code in Java, he is been in a panic situation. He do not know like how to handle. Okay, so where on the other hand, here we can say Sam, he is having a code, like he is having a code in which gives him the flexibility, like he can write in any language. Okay, so he can write using any, let's say Swift, he can use Ruby or Java, anything. And although he is being more familiar with Swift, so he decides to use Swift. So what you can see here, Sam is being more flexible, he is more open to the code, like he is having independence, like whatever language he can choose he can write. But here the situation for Adam is very tough. He have to write a code in a language that is being specified, that is Java, and the things are not in his favor. So this is what dependency inversion means. The dependency inversion means we should have something like, let's say any code like that is flexible in any language. To be honest, like it is flexible to like mold itself into any other way. So this is basically, let's say you have a framework and Sam wants to use that framework in Swift language. He is very happy and he can do it. But whereas if Adam is using that framework, he has been forced some, he has also some framework that has been forcing him to write in Java only. So things are not good for Adam. So we have to write our code in such a manner, like if other person is using, he is not forced to do something. He is open, his hands are open to write the code in his own way, in his own manner. So this was a simple real world example I wanted to teach you. Now let's jump on to the coding. So in the coding, we will be going with first baby steps. As the first we saw, like we have the single principle. Okay, so we will go up with using these examples only and just think about that. So single responsibility principle, as I was saying. So we have, let's say, a child who is having a routine. He is eating, he is sleeping, and okay, and then he is playing. So he have few routine. So what is the thing, like in this one routine, class is handling many of the activities that are being done. This is not a good approach. It's better you can make different classes, because one class is handling many functionalities. As you can see, it is handling 3 functionalities. That is not proper coding practice. So what we can do, I have made 3 classes. I have just made the code divide into smaller pieces: eat, sleep, play. So this makes my things easy. If I have to debug them when I have some errors, it's make easy. I know like the error is coming in the eating, I have to just look at the eat class. So this is how I am doing, just making one class responsible for one function. Here one class was responsible for 3 activities. Now here eat, sleep, play is having 3 classes. 3 classes, and every class is having its own function. We are not mingling up the things. This helps us to make write a clear code. This helps us to in future to debug things very easy, because if you know, like if there is some error coming in the sleep function, you need to just go and hop to the sleep class. So you will get like, oh yeah, here is the error. But if you would be doing here, so you have to look over unnecessary functions as well, and then you have to see. So this helps us. This is what single principle means, like one thing, one class, one function, simple. Okay, so here you have a structure, you have one structure, or if you are making, so it has one functionality. Every thing should have its clear functionality. You just ask yourself, what is my class doing? If the answer is simple, it is let's say eating here, so it's simple. But here if you ask routine class, what is my class doing? It is eating, it is sleeping, it is playing. Do you know yourself it is doing 3 works? Just ask a question, what is my class doing? If the answer is in one single functionality, simple, you are done. You are using your single principle. So this is a simple example. After this, it was simple. Now we will look over open close principle. Open close principle, as I told you, it was like we should not touch the foundations, and we should just only decorate the foundations, or we can just add up to the foundations. It's not good approach to touch the foundations. As you see, like here I have a string, we have a string class. So what I did an extension to the string and I added my function. I just want to append the dollar to every string that I input. So what I did, instead of just touching the string class itself, I just extended that class and I wrote my function, and simply I just wrote my function here, str.append. As you can see now, hello, and we have a dollar being printed. So I did not touch the existing functionality of the string. I just made my string more reusable, or I just made my string giving more functionalities to it. We are adding, we are not touching the basis or the basic foundation. So this is what I mean by open close. Open means everyone can use it. As you know, this string function, like this string class, everyone can use it, but it is closed for modifications. I am not allowed to modify the string class itself. I have extended it, and then I have added the more functionalities to the string. Okay, this is how open close. Open means I'm open for more functionalities, but I'm closed for my own internal modifications. This is a simple example. After this, we come to the Lisk substitution principle that I taught you. So in the Lisk substitution principle, we can see we have a class multiply, and this is just simply multiplying the numbers. Okay, here I have multiplication class, that we can say this is the simple child class. So this child class is inheriting multiply class. Now what I did, I override the multiplication function or the parent function. What I did, instead of now multiplying, I did addition. So you see, like when you will be calling this multiplication and you call this multiply numbers, so this is wrong. It will give me the output 10 plus 10 gives me what? 20. But you know, like, hey, my parent class was supposed to do multiply, and the answer I was expecting was 100, but how come it is 20? So the answer is like, because you have touched or you have changed the functionality of your parent class, and this is not allowed, because your parent class functionality should not be changed. You are overriding them. Okay, if you wanted, you can do, like, you can also override them. You can just multiply the functions. That's easy. The things are fine. You are overriding, but you are maintaining their originality. You are also doing the same work that your parent class was doing. So this is a wrong example. So what we can do, we have a multiplication version 2. This is the another child. Then this child was smart enough, they wrote another function, add number. They did not touch the existing functionality of the parent class. They just wrote another add function, add number, and then they wrote their own functionality. So what happened in the second child, multiply gave us the correct answer, because the parent functionalities are not changed, and we have the add number, and then we are getting both answers are correct. So this is better approach, because the parents functionalities are being not changing. So what this means, like when we are making some new extensions, we should make sure like the previous parent or the inherited things are not getting changed. After this, let's come to the another principle that we were talking, interface segregation. So as I told you, in the interface segregation, here I have made a protocol that's have some activities, let's say play, study, mathematics, music. So this is my student, and he is doing for all the activities. But the point is, my student got tired and he only just want to play. But I cannot, my hands are tied, because I have to implement forcefully the study, maths and music. Why I am forcing my user to implement these three functions? So here comes the thing, like we can segregate our functions. Okay, so what I did, I segregated. I made another protocol that is having only study and maths, that comes under academics. Then we have sports, and then we have extracurricular activity. So my second student, he or she can have all the protocols, like if he or she want to take part in all the parties activities, then they can extend all the protocols and then they can write. But if on the another hand, if my student is more interested in the academics and they do not want to take part in the extracurricular activities, what we can do, we can just simply only extend to our sports, and then we can just make it, and things will work fine. So here my student is having a lot of flexibility. It's just like when Lily went to the grocery store, she should not be forced to take a candy. She got her $1 back. In the same manner, this student is not forced to study and play music. Here we gave the student the flexibility, you can play only. So by how we did, we segregated the things. We divided the things into smaller parts. That makes things more and more easier, rather than for this student the things were very hard, as only all the activities have to be performed in one single protocol and the segregation was not done. So this is a better approach for us. After this, coming to the dependency inversion. Dependency is inversion principle, as I told, like Adam was being forced to write codes in his own not in his own language, and was forced in Java. But whereas Sam was indeed happy, like he can write in his own language. So here we have, let's say, in the same, we have a function protocol. Like here we have the protocol that has a function payment process. Okay, so now let's say I have made this a function, and this can be taken up by any other class whosoever wants to implement. I have made it in a flexible manner. So let's say I have to process a payment through PayPal services, I can just use that function and do my things that I want to do. In the same manner, if I want to go with the Apple Pay and I want to process the payment, I can just take this protocol and do my functions. So this makes my things easy, like anyone can use it, and then we are not forcing anyone. Here, like here you have to write this code in this manner, so things are easy for us. Another way I can tell you, like, is like, let's say we have a function decode, like we use JSON decoder in our classes, so we make sure like the JSON decoder is also, we write it in such a manner like it is also, it can write all the, it can decode any type of the, here it can decode any type of our element that we want, or a passing file or JSON, any type. So here we are not specifying, this is what, like any other function can use it. Like we, if I had it made it to string, then the things would have been not in my favor. Why? Because now I have to make sure like the things are only string type only, and then the string only can be decoded. But things are not good, because every developer will have to write their own function for integer, for double, for so things are not in the favor. But here, if I make it in a generic manner, this means like any developer who wants to decode their JSON, they can just pass their JSON file and things would be very easy for them. So this is how we can have the dependency inversion. Like we do not have any particular dependency or data type of this. Anyone can come and then they can use it. In this manner, same we were using, like anyone can use my payment process method and then they can just simply use their, do their work. This is how things are working. So if you like this video, please go ahead and subscribe to the channel and keep watching. Thank you.